All right, ladies and gentlemen, here we go. We got a real life example, not exactly one I would have written, but it works. We need to be able to take each one of these six. I'm going to call this 1, 2, 3, 4, 5, 6, and see if we can rewrite them using the volume formula. And if we can't, then our answer is we can't. The answer is no. I'll cross it off. If we can, I'll circle it, okay? So first, we have to remember that volume is equal to the base of our shape times our height. That's going to be extremely important. I'm going to move over here because I feel like I went way out of frame on that last part. So here, B is equal to the base of the area of the base. And our base is a circle here, so the area is pi r squared. So we got to use these two facts to just combine them and make something. So what that means is I'm going to replace b over here with pi r squared, and that's going to be times h. And then I want to do two things. I also, sorry, I kind of skipped ahead on this one, but what I also got to realize is r is equal to h over 2, which also means that h is equal to 2 times r. And one of the reasons I know that is because I need that is because they use an r here, but they use an h down here. So I need in terms of r and I need in terms of h. So I need to know what each one are going to be. I just did. So here, where I just put the star, I'm going to be using this in place of, but what I really want to do is keep things in terms of r, is I'm going to be using pi r squared times 2r. Well, that's the same thing as, I'm going to skip one more line just so it's clear. That's the same thing as pi times 2, because remember, order of multiplication doesn't matter. And actually, how we like to notate it in math is we like to have actual numbers, then any variable that represent numbers, then any variables we haven't defined yet. In this case, I haven't defined r with an actual number value, so it comes last. But this would have been r squared times r to the first, which is r to the third. So 2 pi r cubed. And what we should notice immediately here is, yay, 1 works because we already have this formula in terms of r. Now the question is, can we rewrite that in any way, shape, or form? Well, we kind of do for h, and it looks like the rest of these are all in terms of h. Here's h, there's h, there's h, there's h, there's h again. So now that I have my 1 in terms of r, I want to go ahead and put it in terms of h. So I'm going to put h back in. So I need to look here and say, okay, well, this is the same thing as 2 times pi h over 2 to the third, which is the same thing as 2 pi times h. That's a weird h, almost looks like it's turning into a b, so we'll fix that real quick. H to the third over 2 to the third, which is the same thing as 2 times pi times h to the third over 8, which is the same thing as 2 pi times h to the third, all over 8, because this would have been over 1, and 1 times 8 is 8. Okay, so the question is, do we have something that looks like this? 2 pi, so I'm looking for a 2 at the beginning. I don't see one. So I don't have anything that looks like this. So that doesn't mean I'm going to go nope, 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 and just cancel everything. I don't want to do that. What I do want to do is see if there's different ways I can rewrite this. Now, I hadn't really gone over it before, but this is a great place to kind of bring in the idea of, oh, wait, I hadn't simplified yet, sorry. I have a factor of 2 in the numerator and 2 in the denominator. So that means they cancel, and it's going to be pi times h squared over 4. I got ahead of myself and just skipped right past fully simplifying, but here we go. This is what we actually use, not this one. All right, so we're using pi h squared over 4. I know that I've got a pi h squared over 4 as option number 4. So yay, this is a good one. This is one of the expressions that shows the volume of the cylinder. But do any of the others become the question? Because we have a 4 here in the denominator, I need to double check it. There's no h to the third, so number 5 is not it. So again, I don't have a third here, so number 6 is not it. I don't have a third for my h here, so 2 is not it. And let me check this because I don't think I've gone over it yet. We can actually rewrite this so there's no denominator. By the way, this works for any fraction you've ever worked your entire life. I wish there was a way to really get to introduce this earlier, but even now it can be overwhelming to think of negative exponents, okay? So this can be rewritten as pi h squared times 4 to the negative first. Because we have to realize that this is actually 4 to the first, and anything to a negative power means move it to the opposite or move it from denominator to numerator. So we can make 4 to the negative first. We can't dismiss it just because we didn't have a negative exponent. So option number 3 here, we couldn't dismiss just because this was negative. How we dismiss it is I don't have the same exponent on h, and I don't have a way to get rid of an h. So the reason 3 is not an option is not because there's a negative exponent, but because there aren't enough exponents on the h's, or on the h. So to be able to solve this took a while, but really what we did is we solved the volume of the cylinder in terms of r, and then we solved it in terms of h. And we looked for different ways we could use negative exponents or even 0 exponents, which didn't come up, but even 0 exponents. We could use those rules to rewrite meaning and keeping the same values to be able to see different ways of writing all the same stuff. Welcome to really higher level math, and the idea of where physics comes in is how we can take something as simple as distance equals rate times time and get, Einstein's theory of relativity, that the distance formula is in there and parts of it derived and things like that because there's time involved. And not just that, that's really the basics of a lot of the things we do. So we started with getting an equation in terms of one variable for the volume of the cylinder shown. We then made sure to find the terms of both radius and one in terms height. After we did that, we looked for different ways to use negative exponents to be able to simplify it and show it other ways, and we found 2 total ways.